Hi, good morning. Today we are going to continue to learn how to find the area enclosed by two curves. So let's review a little bit. Take a look at that question number 1. So we have region R be the region enclosed by y equal to xq and y equal to 4x in the first quadrant. Find the area of region R. So for this question, if you want to find the area enclosed by these two curves, so what we learned before is you're going to draw rectangles, infinite number of rectangles, and then you will find out that for the base is equal to delta x, and the height is a function of x. It's bounded above by the top function and below by the bottom function. So here this is the top and that is the bottom. So the h of x is going to be bounded by the top function, which is the line for x, and the bottom function, which is xq. And then we are going to do is using the integral a to b, top function minus bottom function, and then dx. So now over here, what should be the top function for x? What should be the bottom function? X cubed. So now we're going to have 4x minus x cubed dx. That is h of x. So now, what should be the a and b? So you look at this piece over here. You will find out that this is the interval. The smallest is going to be x equal to 0. And then the highest is going to be x equal to 2. If you go this way, you will find out that the smallest x value is 0, and then you go move, 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 and move. The biggest x value is 2, so therefore it's 0 to 2. So now we had the integral. The next step is just to integrate. So we're going to integrate. So we use the technique that we learned before. Okay, so we simplify. And then we do substitution. And here you get 8. So the area of R is 4. So we finished question number 1. Now let's take a look at question number 2. Question number 2. Find the R. Let R be the region enclosed by y equal to xq and y equal to 4x in the first quadrant. Find the area of the region R with respect to y. So basically it's the same diagram if you look at it. You still had the y equal to 4x and y equal to xq. But the question asks you to find the area of the region R with respect to y. What it means is use horizontal rectangles and dy. That's what it means. So now that means you are going to draw horizontal, okay, rectangles. You draw infinitely, you draw a lot, infinitely many horizontal rectangles. Okay, so now for each rectangle, the base is delta y. So look at here, look at this one over here. Okay, so you're going to have your y value, subtract your y value. So delta y. So when you drew infinite many horizontal rectangles, so for each rectangle, the base is delta y. And then how about the height? H. So the height H is H of y, because now this time you're calculating your height horizontally. So now you are going to make the function in terms of y. That is why your h is h of y, because you are going to subtract this way. So now, in order to find the length, shall we always do right minus left? Only when right minus left you get positive. If the other way around, you get negative. So over here, my right is going to be y equal to x cubed. So you're going to solve for x. You're going to make the in term of y. So undo the x cubed, you do q root. So therefore x equal to q root of y. And then this is going to be the left. Okay, if you look at this way. Okay, left, right. And then you will have your function y equal 4x. And you solve for x. So therefore divide by 4. So x equal to y over 4. So my right function is x equal to square root of or cube root of y. And my left function is x equal to y over 4. And then you have to find h of y. Right function minus left function is subtract. So the x will be cancelled. So you get cube root of y minus y over 4. So now, using the same idea, integral, you got h of y and dy. That come from the Riemann sum. And over here, it cannot be x value. So you have to be the y value. So it's c to d. C and d are y values. So now we are going to have integral. So my right function minus my left function and dy. Because you're going this way this time. Okay? All your rectangles are this way. So what should be the lowest y value? The lowest y value is 0. You start over here. What should be the biggest y value? You go, and then you stop at 2,8. So therefore the biggest y value is 8. So now we had our integral. So it basically is integral c to d, right function minus left function dy. Y, and y, they had to be the same variable. Now the next step is just integration. So we're going to integrate. I'm going to rewrite it. So you have to 8 y to the 1/3 minus 1/4 times y. Now I'm going to integrate y 1/3 plus 1. 1/3 plus 1 is 4 over 3. And minus 1/4 times y squared over 2. Okay, I no space, I'm going to go to over here. So this flip over, you get 3 over 4. And times y to the 4 over 3 minus 1/8 y squared. Okay, now I get 3 over 4 because this is a cube root. So I'm going to do cube root of y to the 4th power minus 1/8 y squared. Now do substitution. 3, 4, cube root of a to 4 power minus 1, 8 times a squared minus 0. So now I get 3, 4. And you have the 2 to the 4 power. That will be 16 minus 1, 8 times 64. Now we can simplify. This is 1, this is 4. This is 1, this is 8. So now I get 12 minus 8 equal to 4. So we found the area is 4. Of course, it had to be 4 because number 2 and number 1 is basically the same question. We're just solving it with two different methods. Number 1, we're using vertical rectangles. So therefore, the base is delta x. So therefore, you had to use the top function minus the bottom function dx. And then number 2, the question forced us to use the horizontal rectangles. So therefore, my base is delta y, dy. So therefore, I had to use the right function and the left function. And the area never changed, so it's still 4. Now let's go to question number 3. Question number 3. It said let R be the region enclosed by the graph y equal to 2x and y equal to x squared in the first quadrant. And then you have to find the area of R with respect to y. So for this question over here, because you were forced to find the area with respect to y, so that means you have to use horizontal rectangles. So you use horizontal rectangles and use dy. So that means the formula is going to change into c to d, right function, minus left function, and dy. In other words, is c to d integral h of y dy. Okay, so these two are related. Definitely I want you to remember both, so you would know why we're using right function minus the left function. So your h is going to be bounded by the right function and the left function. So this is the right and this is the left. We always do right minus left to get positive length. 2 minus 0 is positive. The other way around you get negative. So we had the y equal to x squared. So solve for x, you have to square root y. And this your left function, y equal to 2x. You solve for x, so x equal to y over 2. So now my right function is x equals square root of y, and my left function is going to be x equal to y over 2. So now the height, you're going to subtract right minus left. When you subtract, the x cancel, so you'll get square root of y minus y over 2. H is a function of y, Now we're going to substitute into the integral. So now we're going to get integral square root of y minus y over 2 and dy. Y, and y, they all function of y. If you have an x over here, that means you forgot to change it into the x equal to something with y, had the internal y. Now your c and d had to be the y value. So look at here, the y value. You begin over here, 0, and you can move up, and your biggest y value is 4 because you start at 2, 4. The smallest y value is 0, and the biggest is 4. So therefore we have 0 to 4. Now the next step, we just have to integrate. Now we're going to do 0 to 4, y to the half minus 1 half times y. Okay, and then we're going to flip this over, become 2 over 3, and y to the 3 over 2 minus 1/4 y squared, because 2 times 2. And now we're going to do 2/3. This is the square root of y to the 3rd power. Now we do substitution. So 2/3 square root of 4 to the 3rd power minus 1/4 times 4 squared and minus 0, because you substitute it, I'll get 0. So you get 2/3, and square root of 4 is 2 to the 8. 2 to the 3rd is 8. And then you're going to simplify from here. Now you got 16 over 3 minus 4. And then you continue. And subtract, you got 4 over 3. So the area is 4 over 3. So we finished question number 3.